So naming of sets and elements of a set. So how we are going to denote the sets, how we are naming it. So there are so many number of sets, we can ourselves define a set. So after defining this, how are you going to write? Okay, that we'll see. Okay, how are you going to write the set? So we usually denote the sets by uppercase letters like A, B, C, D. Okay, now every set is denoted by some letter, some letters. Okay, so anything symbol you can use, but it is a convention that uppercase letters are used to denote a set like A, B, C, D, E, F, G, X, Y, Z, like that. Okay. Now generally the objects inside the set are denoted by with a small letters like small a, small b, small c, like that. Now this you note that generally these are the fixed in every textbook, any textbook. So they are standard, like of course you can change if you want, but generally it is convention that natural numbers are always denoted by A, and all integers are Z, negative and positive and 0. Set of all rational numbers by Q and real numbers by R. Okay, so these are the generally denoted by the sets. Okay, now we'll see, for example, set natural number set n. So we'll write like this with the flower brackets. What are the natural numbers? Natural numbers, all the natural numbers. What are the natural numbers? 1, 2, 3, 4, 5, so on up to infinity. So then what is the set of integer z? Z is what? Negative and positive, minus 3, minus 2, minus 1, okay, 0, okay, 1, 2, 3, 4, 5, so on, okay, Z. Okay, all rational numbers, which are all in the form of rational numbers Q, which we can write in the form of P by Q, where P and where Q is not equal to 0. Okay. So here in this integer, 0 is actually neither positive nor negative, but we can consider in both the case, because 0 is also an integer, right? But it can be neither positive nor negative. These minus 1, minus 2 are negative, plus 1, plus 2 are the positive, right? So like this we can define. Now I will show you some other example. Suppose we have taken in the previous case all the even numbers. So suppose if you denote with even numbers E, what are the even numbers? Start from 2, 4, 6, 8, 10, so on. Infinite set, it's infinite. Okay, suppose same even numbers less than some 12, less than 12. So 2, 4, 6, 8, 10. We'll stop here. Less than 12 we said, because even numbers less than 12. Less than 12 even numbers means 1, 2, 4, 6, 8, 10. Like this. So all odd numbers. If I call O is all odd numbers, what are odd numbers? 1, 3, 5, 7, 9, 11, so on. Okay. Similarly, if I say odd numbers less than some 15, odd numbers less than 15, odd numbers less than 15, 1, 3, 5, 7, 9, 11, 13, less than 15, that's all. We'll stop here. Okay, less than, right, less than 15 means up to 13. Okay, so like this we should be able to write a set. So I'll show you some more. So a set is denoted by some capital letter X. All the elements are written here. Okay, all the elements are written in a flower brackets by putting flower brackets, X, some Y, like this. Okay, these are also denoted by some diagrams also. We can write like this. Suppose Z is the element just containing 0, so 0 we can write only, or you can write some other, some set K. Okay, K is a set of all girl students in your classroom, all girl students. So you just write all the names of girl students by putting comma here. Okay, now suppose R is a set of all boys in your class, all boys in your class. So well defined. What you are going to write, all your boys names you write in your class, that's all. Okay, so similarly we can say this way also. A set, like we can denote like this, is a set. This is a Venn diagram which we'll call. This is set A, this is set B, like this. Okay, so these are the naming. And there is another method is there, that is called roster form. Roster form, this is roster form of denoting set. In this case we will write the definition, the principle or the character or the property definition of the set. For example, A is a set, X such that, we will write X is such that X is a set, X is an element in the set A such that X belongs to even numbers. Even number. So what the numbers will come? All even numbers. Which are the even number? 2, 4, 6, 8, 10, 12, 14, so on. X such that X is an even number. Just we have written that A is a set and we are writing the roster form. X such that X is an even number. What are the even numbers? If I write all these, okay, I'll write one more. See, suppose there is a set B. We'll write the roster form X such that, we'll write X such that X is an odd number. What are the odd numbers we have? X is an odd number. What are odd number? 1, 3, 5, 7, 9, 11, 13, 15, 17, so on, infinite. Okay, right? Okay, like this we should be able to write in the roster form. So roster form and the set builder, this what we call as set builder form. This is called set builder form, and the roster form is all these things we are writing here. It is a set builder form, means like this we are writing. Okay, you can show here this one. Okay, these are the two methods we are writing. So writing all the elements we'll call as a roster form, and with a property we are writing, we are calling it as a roster form. Okay, we'll stop here.